Have you ever wondered how your social media feed seems to load new posts in an instant? Or how a shopping app can show you product recommendations almost before you finish typing? Well, that's not magic. It's a really clever technology called database caching, and it's the secret ingredient behind the speed of the modern internet. In this explainer, we're going to pull back the curtain and show you exactly how it works.
So let's start with that question. How do our favorite apps feel so incredibly responsive, even when millions of people are using them at the same time? You see, a traditional database, where all that core information is stored, it just can't keep up with that many requests without slowing to a crawl. So something else has to be at play here.
And the answer is a simple but incredibly powerful idea called caching. The concept is pretty straightforward. You store the data that gets used most often in a temporary, super high-speed layer that sits between the user and the main database. This one change takes a massive amount of pressure off the database, and it's what allows modern applications to absolutely fly.
So here's how we're going to break it down. First, we'll look at where caches actually fit into a system's architecture. Then we'll explore the two main ways they behave. We'll also look at a very popular real-world tool called Redis. And finally, we'll bring it all together to see how you can design a really smart caching strategy.
Okay, first things first. Location, location, location. Where you decide to place your cache is a huge architectural decision, and it's not just about what server it's on, it really defines the relationship between your cache, your application, and your database. Let's explore the three main options.
This table really lays out the trade-offs nicely. You've got your database integrated cache, which is easy because the database itself manages everything, but it's often small and limited. Then there's a local cache, which lives right inside your application. It's incredibly fast because there's no network trip, but it's also totally isolated, which doesn't work well for larger systems. And that's exactly why the remote cache has become so popular. It's a dedicated, shared service that all parts of your system can talk to, making it perfect for modern distributed apps like a streaming service or a global online store.
All right, so we know where a cache can live, but how does the data get into the cache in the first place? Well, this is where two fundamental patterns come into play. These patterns really dictate the when and how of updating the cache.
Okay, the most common strategy is called cache-aside, but you'll also hear it called lazy loading. And it's a reactive approach. Here's how it works. The application first asks the cache for a piece of data. If the data isn't there, that's what we call a cache miss, the application then goes and queries the primary database. It gets the information, and only then does it add that data to the cache for next time. So the data is only loaded when it's first requested.
So what's the trade-off here? Well, the huge advantage of cache-aside is its efficiency. You're only storing data that's actually being used, which keeps your cache lean and cost-effective. The downside? The very first request for a piece of data is always going to be a bit slower because of that initial cache miss. It's a bit like ordering a pizza. The first time you order, you have to wait for them to make it, but every time after that, it's ready to go.
Now, the second pattern, write-through, is completely different. It's proactive. It pretty much flips the logic. So instead of waiting for data to be requested, the cache gets updated at the exact same time as the database. Anytime your application writes new data or changes existing data, it immediately makes that same exact update in the cache. And this shows us the other side of the coin. With write-through, your cache is basically guaranteed to be up to date. This means faster performance and fewer cache misses, which is absolutely critical for data like, say, your bank account balance or a product inventory count. The disadvantage, you might end up writing a lot of data to the cache that nobody ever asks for, which can make your cache larger and more expensive to run. So we've talked about the where and the how of caching strategies. Now let's look at a real-world tool that developers use to bring all these concepts to life. Redis. It's one of the most popular choices out there for building a high-performance remote cache.
So what exactly is Redis? At its core, it's an open-source in-memory data store. You can think of it like a lightning-fast dictionary. You give it a key, and it instantly gives you back the value. And that phrase, in memory, is really the secret sauce here. By keeping all of its data in system memory, or RAM, which is thousands of times faster than a traditional disk drive, Redis can read and write data at incredible speeds.
Its power really comes from these characteristics. That in-memory speed is the headline feature, enabling things like real-time gaming leaderboards or instant session management. But crucially, it also offers durable persistence, which means your data isn't just gone if the server restarts. Its key/value model is simple and flexible to work with, and it can store more complex data types than just simple text, which makes it an incredibly versatile tool.
Okay, so now we have all the pieces of the puzzle. We know about location, we know the different behavioral patterns, and we have a powerful tool like Redis. So how do we put it all together into a cohesive strategy? Well, the truth is, the best caching strategies don't just pick one pattern. They cleverly combine them to fit the specific needs of an application.
So here are the key things to remember. First, think hybrid. Use a write-through pattern for data that absolutely must be fresh, like a user's profile info, but use lazy loading for almost everything else, like comments on a popular article. Second, data gets old. You need to set expiration times to keep your cache from getting filled with stale information. Third, for modern apps, a remote cache is almost always the right choice. And finally, always remember this is a balancing act. You're constantly trading performance gains against cost and complexity.
And that brings us to our final, most important point. A caching strategy is not a set-it-and-forget-it kind of thing. The digital world is always in motion. User behavior changes, the amount of data grows exponentially, so the strategy that's perfect for you today might be inefficient tomorrow. And that leaves us with the real question. How can you design a caching strategy that's not just fast today, but also intelligent and adaptable enough to evolve right alongside your application?